Hello students. Today I want to explain to you a little bit about some story problems with inequalities. And in order to do that, we've got to talk about what some of the words are that mean inequalities. And I have a table here at the top of the page that explains some of the words and how they mean different inequalities. First of all, we have on the right hand side, we have greater than. This just means is greater than. If you see the words is greater than, you can simply use the greater than symbol. If we have this particular symbol, that means is less than. So if you're reading a sentence and it says is less than, you can simply use the is less than symbol. What's a little bit more difficult is when we see, for example, the words at most or the words no more than. Really what this means is this is the biggest that a particular number could be, but it could be smaller. And so it actually translates into less than or equal to. Also more difficult is the phrase at least and no less than, which means that's the smallest it could be, but it could be larger than that. So it translates into greater than or equals. So with that being said, I want to go down to the bottom of the screen here, and I want to talk about an example. So we have 12 subtracted from 3 times a number is less than 21. Find all numbers that make this statement true. This is going to be for us an inequality. So first of all, we need to chunk this up. So let me get my blue pen out here, and I'm going to chunk this for us. We're first of all going to have 12. Subtracted from is a chunk. 3 times a number is a chunk. Is less than is a chunk. And we have 21. So what we're going to do now that we've chunked this up is make this into an inequality statement. So remember this phrase subtracted from? We know this means minus. But what we have to remember is that means we want to reverse the order. So in other words, it's something minus 12. So we're going to write in minus 12. But we have to figure out what goes in front. And that is 3 times the number. 3 times the number for us is 3x. And bear with my kindergarten writing here because it's not so easy writing with your finger on an iPad. So then we have is less than 21. And now all we have to do is to solve this. So the first thing I'm going to do, add 12 to both sides. That gives me 3x is less than 21 plus 12 is 33. Let's move my screen up a little bit here. And let's divide both sides by 3. And so what we get is x is less than 11. And the way that you can explain your answer is any number that's less than 11 will work here. Now keep in mind, 11 will not work. It has to be less than 11. That means it could be 10 or 9 or 8, but also any of the fractions or decimals that fall in between those numbers. So let's go further on down the page. I've got another example for us to do together. And we have twice a number subtracted from, so again we're going to have the reversing of the order. 35 is greater than 15. Find all numbers that make this statement true. So again, we're going to start out with twice a number subtracted from. Let's chunk this up. So twice a number is a chunk. Subtracted from is a chunk, 35 is a chunk, is greater than is a chunk, and 15. So here's what we're going to do. We have twice a number subtracted from 35. So that means that the twice a number, which we know to be 2x, is actually after the minus sign. So minus 2x. And what it's being subtracted from is 35. So in front, we're going to have the 35. Then we have is greater than and 15. So there's our inequality. Now all we have to do is solve it. First thing I'm going to do, subtract 35 from both sides. And I'm going to bring down my negative 2x is greater than, this is negative 20. Now what I need to do is divide both sides by negative 2. And remember, negative 20 divided by negative 2 is going to give me a positive 10. I'll have my x over here, but since I divided by a negative number, I've got to flip my sign. So again, I get x is less than as an answer. So x is less than 10, and what that means for us is that any number less than 10 will work here. Okay, those direct translation problems are probably easier than what you think of as a traditional story problem. We do have a story problem here that we're going to take a look at and try to figure out. So we have Marie Chase and Jonathan Edwards are having their wedding reception at the Gallery Reception Hall. They may spend at most $2,000 for the reception. If the reception hall charges a $100 cleanup fee plus $36 per person, find the greatest number of people that they can invite and still stay within their budget. So first of all, we have to figure out what we're going to identify as X. And what we're going to use as X here is the number of people. So let's write that in. X equals the number of people. I guess we could call them guests. Okay, so we have the number of people. So now we've got to figure out how much it's going to cost to have this wedding hall. So it's $36 per person, and X is the number of people. So this is 36X. Okay, that's going to be the amount per person times the number of people, plus there's an additional $100 fee. And they may spend at most. Now, if you remember from our prior page, so remember now, at most means less than or equal to from our chart. So this is going to be less than or equal to $2,000. All right, now we have to go about solving this. So let's subtract $100 from both sides. And we've got 36x is less than or equal to $1,900. Hopefully I have a calculator nearby, and I do. So now we're going to divide both sides by 36. And let's calculate 1900 divided by 36 is going to give us 52.777. It actually has more sevens, but that's okay. Here's the thing that we've got to ask ourselves. We have to figure out how many people we can invite. And that number is less than or equal to 52.777. Now, I know that we usually round this up to 53. However, if we invite 53 people, we're going to go over our budget. So we can only invite 52 people. We can't invite 0.7 of a person. So our answer is 52 people. So let's go ahead to the next example further on down the page. And this one happens to be about college tuition. Kasanga, interesting name, is eager to begin his education at his local community college. He has budgeted $1,500 for college this semester. His local college charges a $300 matriculation fee and costs an average of $375 for tuition, fees, and books for each 3-credit course. Find the greatest number of classes Kasanga can afford to take this semester. This is going to work very similarly to the example that we just did. What we have to do is first figure out X. X is going to be how many courses he can take. So X equals the number of classes that he can take. So next thing we're going to do is we're going to figure out how much going to college is going to cost him. So it's $375 per class, and X is the number of classes. So we're going to start out with 375X. To that, we're going to add the $300 matriculation fee. All right, $300 matriculation fee, that's just like a general fee for being a student, and yes, they do charge you that. This also all has to be less than or equal to $1,500. Because that's all he has to spend this particular semester at college. So now we need to go about solving this. So let's subtract 300 from both sides. And here's what we get. 375x is less than or equal to 1,500 minus 300 is 1,200. Our next step is to divide both sides by 375. And let's get a calculator out here. And we need to divide 1,200 divided by 375. And what we get is, again, a decimal. It is X is less than or equal to 3.2. Now, you can't take a decimal amount of a class. You can only take a whole number amount of classes. So the most classes that he can take is just 3. So that is our answer, 3 classes. If he takes that 4th class, he's going to go over his budget. Enjoy your homework. Talk to you later.